Hello there, and welcome to another edition of Catalysts, a platform for the scientific community to connect, discover, and transform. This is your host, Kedar Aras, and today it's my distinct pleasure to connect with our next guest, Dr. Ken Spitzer. Dr. Spitzer is a professor of internal medicine and the director of the Nora Eccles Harrison Cardiovascular Research and Training Institute at University of Utah School of Medicine. Dr. Spitzer's lab focuses on cardiac cellular physiology to include intracellular pH regulation, calcium handling, and electrophysiology. Dr. Spitzer, thank you for joining us on the Catalyst podcast. To begin with, could you share with our listeners how the transition for you happened from grad school? I understand you did your PhD at the New York State
State University
of New York
in
School of
Buffalo.
Medicine.
Yes.
Right. Can you walk us through how that transition happened from PhD to postdoc?
Okay. Can I go back a little further?
Absolutely.
Because I think it's important to indicate that a lot of us have not very linear routes to where we ended up. I mean, I had a strong interest in biology, so I went to a college and got a degree in biology, and then I got a master's degree in zoology because I was interested in comparative physiology.
Right.
But and I was interested probably working in a biology department, but then I went into the Army and I was involved in research at an Army's burn unit and worked with some chest physicians there, and that's where I developed a real interest in working in a more medically oriented field and began to realize a lot of great research was being done in medical schools, particularly in the cardiovascular area. Although at the time I was really interested in respiration, so I went to State University of New York in Buffalo, which had a very strong respiration program there, to graduate school to work on my PhD. And I fully intended to work in respiration. I even had a mentor set up and everything. And we did, as many graduate programs did, I had a rotation through various labs. And I went into a lab where they were doing cardiac electrophysiology, putting electrodes in heart cells. And in those days, they didn't even have single heart cells. They were just little pieces of tissue. And I just thought this was really great. And so anyway, I went back and talked to my respiration mentor and said, I think I want to do this. And I'll never forget what he said. He said, look, the main thing is to get your union card. I have your PhD. It kind of doesn't matter what area. So he was great. And so I worked on cardiac electrophysiology, and I graduated in '77. And I wanted to extend that expertise because it was very focused. It was focused on the effects of pH on cardiac electrophysiology. But at that time there was a big interest. All the fluorescent dyes weren't available that have just been tremendous in studying the cellular calcium regulation, other pH regulation. So there was a investigator here, John Walker, who was kind of the father of using ion-selective microelectrodes that had a sensor in the tip of the electrode and you could measure ion activity. So I came out here, did a postdoc with him, and was then sort of firmly interested in the cardiac field. And again, just was serendipitous, a job became available here at CBRTI, which was a much smaller institution then. We only had one building, now we have three. And so they hired me after my postdoc, and now I'm the director here. And the initial challenges, they did not have anyone working with cardiac cellular electrophysiology. It was whole heart electrophysiology. So the challenge was to get the lab together, and they were very generous of the resources. But I remember getting in my car and driving all over town, buying fittings and tubing and all these things, and it took that is one message I'd like to convey to anyone setting up a lab. You know, one of the things you're kind of protected from in graduate school as a postdoc is what's involved in setting up a lab, which can really be a big deal because you don't, well, understandably, you're not typically involved in setting up a lab when you're a trainee. But boy, it's a real challenge to do that, but you learn. It's a great. There's a lot of downtime in doing research when you do that, but it's a great learning tool to set up a lab. Then a funding issue. You know that we have significant amount of funding here from a private foundation, and of course we're part of the medical school. But the grant issue came up right away, and I had a difficult time obtaining grant funding from NIH, and I was able to obtain some small amount of funding from AHA, but then I finally figured out how to write a grant that made sense and was an interesting topic, and then I was funded for the next 25 years or so. But that was a real challenge doing that. And then I've never had a big lab because I like to do experiments myself. You know, if I get over 2 people in my lab, it's crowded. Okay. So okay. I don't have to. Well, that's just how I run the operation because I'm actively involved in research. Since I've been in this administrative role as director here, it's really diminished my ability to get into the lab, but I still do it. But the writing. We can talk about writing grants if you'd like. You want me to talk about that?
Right. Well, I was kind of if we could talk about research granting.
Yeah.
The question I had, you mentioned earlier about how much effort is involved in setting up a research lab.
Yes.
So segueing from that, I wanted to kind of get your sense on building a research portfolio. Your research primarily is in cardiac cellular electrophysiology with focus on intracellular pH
regulation, calcium
regulation in Purkinje fibers and EC coupling.
Yes.
So the question then becomes is, in order to build a research portfolio, does most of your research ideas come from the data you collect through your organic research? Or is it a combination of that and then talking to people, attending conferences, reading papers, or exposing yourself to adjacency fields?
It's really all of those. And one thing, initially I was the only person. Everybody was doing whole heart electrophysiology here.
Right.
So I was pretty much by myself. And that is not a good situation to be in. So I was the search committee of one that helped find John Bridge. And John was interested, and John still works here, and very interested in an expert on EC coupling.
Right.
So that was really my first major collaboration. So one of the key things nowadays, particularly, you can't be like Newton, where you go off and Sir Isaac Newton, you go off in your lab and think great thoughts and it'll work out for you. Collaboration is really important. So you get ideas from your collaborators, discussing things, even from your trainees. That's a major source of thinking about it, about new directions to go in. But the main thing is you've got to be familiar with the literature, because and this goes back to the grants. In order to write a grant or a paper that's going to be accepted, it's got to be innovative. It's got to fill an important gap in the field and really move the field forward. And that's even more important now. It can be technically beautiful, but that will not be probably publishable or certainly not funded nowadays. It's got to be an innovative idea that is thought to make it's got to have what they call a high impact. Now, admittedly, that's a bit subjective to identify that, but sometimes it's not so hard. If you see a grant or a paper that is technically superb but only incrementally advances the field, then I think that may have been acceptable a few years ago, but it's not so much anymore. In terms of trainees, I've mainly had postdocs.
Right.
Honestly, I've had about 4 or 5 graduate students. They some were in bioengineering. That worked out very well. And that came about as just students saw what I had done on what my interests were on the website and came and talked to me, and we decided it was mutually interesting. Postdocs, I've had a number from Japan, and that was through colleagues that knew what I did, and then they would put me in touch with some people there,
Right.
And then through the collaborations through the years here at the medical school and outside the medical school have been huge. I mean, I can't emphasize enough the importance of collaborators and generating ideas, contributing to research. If you're the only person, you and your trainee are the only person generating the data, because as a faculty member, you've got other responsibilities, teaching, administration.
Right.
So if you're not, and particularly if you're by yourself, like I was initially, if you're not in the lab, nothing's happening, you know.
Right.
So by collaborating, I mean, it's obvious thing, but when you experience it, it's really important. You see, because as a graduate student, you don't really collaborate with anybody, so you do everything. But when you become a faculty member and try to do that, it's very difficult. So what you can do now, if you have you're super funded and you've got a whole group of trainees, then you can sort of view those as collaborators.
Right.
But for someone like me who ran a small operation, it meant that every aspect of a project or a grant, we didn't have to do it. You know, we shared with my collaborator, we shared the contributions to the grant or to the paper. And you know, nowadays multi-PI, not just co-investigators, but multi-PI grants are as NIH funding has become more and more difficult. And I think NIH likes to see that. They like to see people coming together with varied expertise, contributing to a significant problem.
Focus.
Yes.
Yeah.
And so I would, that's an important thing to try to establish early on, is some sort of interaction. And it can be, now, I mean, my main collaborator for the last 15 years is in England, for crying out loud. And it's worked out really well. He sends his people here, he comes here, I go there. And so it doesn't have to be somebody down the hall,
Right.
you know. And you know, that just works out by sort of natural selection.
Right.
But sometimes the collaborations don't work out. I mean, they work out in the sense you'll have a project, you work on it, but it's sort of mutually decided that we probably don't want to do any more on this. But then you can have other collaborations that can just go on for years, as I have with my colleague. And I had Bill Berry, he's a physician in cardiology. We collaborated actually along with John Bridge for many years until Bill retired. And then, and right now I'm collaborating with several people in CBRTI. Within this institute, which has about 50 people, 12 investigators, there's a significant amount of collaboration. So that's a key part of this, I would think.
Well, one of the things I was fascinated about your role as a combination of a researcher, a professor, and a director of a renowned heart research institute was how do you manage to balance all those roles?
That becomes very tricky sometimes. And I teach first and second year medical students too, and you know, about half of our funding comes from the Nora Eccles Treadwell Foundation. Which is a very prominent philanthropic family in Utah, and they've just been wonderful in supporting our institute and the medical school and also the whole university. So a major part of my role is to keep them well informed about what we're doing and try to manage the place in a way that facilitates the needs of the investigators. This is not organized where I'm the king and they do what I say. I mean, these people are perfectly capable of doing their own research. I just try to facilitate that and then make sure there's a smooth interaction between the foundation and them. But how do I do that? I think if I had been thrust into this role suddenly about 20 years ago, I'd have been panic stricken. I can tell you, it's only because that I started as a research instructor. You know, you can't get any lower academic rank than that. And I think it helps to have come up through the ranks and just see how and I never had any real ambitions to be in a leadership position. And they asked me to do it, and the only reason I would have done it is because I love this place. And I like the people here, the type of research. I'm not an administrator by nature. In other words, if I was asked to go be an administrator somewhere else, there's no way I would do it. But to be honest, it's just experience and time. And I've been here 35 years, so you better learn something in that time. So in terms of time management, actually, it's not too bad. I just, well, in terms of teaching, you know, I've been teaching for a number of years, so, 35 years, and so I feel like I have the moves down for that. And I'd say the biggest challenge now is to try to help the investigators and help us as an institution to put ourselves in a better position to secure grant funding. That's a challenge we're working with right now, and so I'm trying to help everyone move forward on that. But I will say, anyone interested in an administrative role better and they want to do research, it's not easy to do that.
You got to be really good at time management.
Yeah, it's not easy unless you've got some great trainees or collaborators. Because sometimes the administrative things have to be done. I mean, because of the demands of the university or whatever group you happen to be working with. So experiments are canceled, you know, or if you're in the middle of an experiment, it's the same challenge that physician scientists face, I think, where they're trying to treat patients and suddenly they're in the middle of an experiment and a patient issue comes up, this administrative thing comes up. So being an administrator is not the greatest role if you want to do research. I mean, I am doing it, but certainly not to the level I think that I was able to do before. On the other hand, I just really love this place. I have great respect and admiration for the people here. And so it's a pleasure for me to be in this administrative role. I'm not trying to, to make a case that don't be an administrator, because in the right setting it can be really rewarding. But it really hammers your research. It did me. I mean, some people are just brilliant. I'm not. All right, I can multitask, but I found it more challenging than perhaps others do.
Got it. Segueing into writing grants, you mentioned how one of the key attributes is to have collaborative research effort with multiple PIs.
I think so.
And also how the idea for a grant should be innovative with high impact.
Yes.
Can you elaborate a little more on those terminologies and what's your perspective on what that actually means?
Well, this is something that NIH has instituted about 6 or 7 years ago, I think, because I've served on various NIH review panels, and they changed the format not too long ago, and impact became one of the highest most important criteria for success. And that's kind of mushy when you think about it, because, for example, some of the hard, real basic science, if you want to say the impact has to do with what its clinical relevance is, well, I mean, it could be years before that is identified.
Right.
And, but So it's a little difficult sometimes to judge the impact as a reviewer.
Right.
And then as the grant writer, it's a little difficult to know what it is. Since there's been such an emphasis in NIH on translational research, although I've heard recent comments from people in study sections that they really haven't abandoned basic research, and basic research grants are still of interest. What most of us have done here in the last few years is switch from a more basic focus to a more translational focus. And what I mean by that is, we don't do human research here, and it's not clinical research, but we'll have an animal model of a disease and try to understand the biophysics of how ion channels, for example, are affected, how EC coupling is affected, those kind of things. So you can sort of do, you've always got to have control animals, so you can do basic research too. So that's been kind of a challenge for us to identify. Like right now, we're trying to collectively identify some projects in heart failure that we can work on, because we've tried, despite what we've heard that they are interested in basic research, we've tried on several occasions to submit very basic grants, and it wasn't a high level of interest. But in terms of impact, what I think has to be important is that not necessarily future clinical impact, although that could be really important. If you can identify a signaling pathway or a drug that can have an impact on some disease state, that would be great. But I think in any given area, like in electrophysiology, if you could demonstrate how this description of this ion channel, its characteristics, has a more global impact on cell physiology. I think I'll give you an example. Some of the research that goes on here, it looks at the structural and biophysical properties of ion channels.
Right.
And that was an incredibly hot area for a long time. But the folks doing that here would be the first to tell you there seems to be less interest in that now. Whereas maybe more interest in how this ion channel is important in a more global functioning of the cell. But at the end of the day, you still have to focus down on very specific things. But so the impact issue is a challenge, because what is a good impact? What is a positive impact in one person's eyes is negligible impact in another's.
It's a beauty in the eyes of the beholder.
Yeah, it's true. But you can have now some grants, like grants for trainees, for example, a lot of the AHA grants, NIH grants, they really focus, it's got to be pretty good science, but they focus on the training potential of this grant. What's the training program that the mentor identifies that will allow this person to become an independent investigator? Now when you get to past the trainee grants, that's where they really look for impact. So I want to qualify that a bit. For people looking for undergraduate grants, for graduate student grants, and for postdoctoral grants, a number of those are designed to be kind of a training grant, and there's a lot of emphasis put on what the training program the mentor is proposing. And sometimes the mentors don't realize this, and they focus so much on the science, and they don't identify all the training aspects this student will receive, not just classwork, but seminars. You're going to meet with them regularly. They may even take as a postdoc. I served on NIH study section for postdoctoral grants, and some of the really good places even have courses for postdocs, and they have a committee for the postdoc. So not almost like a graduate committee. So it's a very organized program. So these people know a lot when they come out, and so that kind of thing really resonates with the funding agencies. But then the grants that you would be interested in as a faculty member, that's where the scientific impact. It has to be. You know, what a danger you can always face in these types of grants is you get so caught up in the beauty of your experimental design and the technical and dazzling people with all the techniques you do.
Right.
You haven't sold this product. It's almost like selling used cars, you know, or new cars rather.
Right.
You've got to convince the reviewer that this is something worth funding and it's going to move the field forward. And the other thing to keep in mind about grants is not every reviewer is an absolute expert in what you've. Now, there will be somebody on the review panel that probably is an expert, but the others will be pretty knowledgeable. So somewhere up front, you better make it real clear that, you know, what is the importance, what gap this fills in clear English that people understand, and that can be a real problem.
It's very interesting.
In
Yeah.
writing grants, you can really go off the rails by thinking that everybody reading this is just an absolute expert in this particular area, because they may not be. And you've got to be able to explain, and sometimes it's almost in kind of simple terms. Almost like, I won't say like telling your parents about it, but it's just got to be really clear what you're trying to do, and just trying to dazzle people with techniques is not gonna do it. It's got to be a really clear explanation of what you're trying to do, and especially how it advances the field. This is something we really didn't understand before, or maybe you have preliminary data that really goes against the conventional wisdom. Now that's where it gets a little tricky, because honestly, NIH is pretty conservative in there. I don't mean as an institution, reviewers are. So they're kind of risk aversion. So if you have a project that goes really against the grain too much without supporting preliminary data, it might be a problem. And I think that's a difficulty with the present situation. It's almost like you've had to do the study before you submit the grant application. Probably shouldn't record that, but I think other people would agree with that.
Right.
You know, that is I think one of the biggest challenges in facing young people going into science nowadays is this funding situation, because, you know, in bioengineering departments and other departments, like here at the University of Utah on lower campus, they have a large teaching mission. They're supported a lot of money from the state,
Right.
and understandably. In medical schools, that is typically not the case, because the teaching mission is a lot less. So the amount of salary support that can be provided in basic science departments, I'm not talking about the clinical folks,
Right.
can be there. The expectation a lot of places is that you get 50% of your salary from grants. Well, nowadays at the National Heart, Lung, and Blood Institute, the pay line is 10%. And in 2003, it was 30%. So here you are, there you are, sort of competing for your salary every 4 years, and they don't even give 5 years anymore, 5-year grants anymore. And it's hard to write sort of a best-selling novel every 4 years. And and I think young people going into science are much more aware of the funding situation than certainly my generation was. I mean, I was clueless about this, although it was a rude awakening with how hard I tried initially several times to get grants and through NIH, and it just didn't work. But I just got better at it, and I got some help and feedback about how to do things, and then the lab was running smoother then, and I had some nice preliminary data, and so once it got going, then I was able to be continuously funded after that. And another thing in terms of collaboration, if you're just talking about money, is not only the intellectual aspects of collaboration, but the fact that you've got you're financially involved in other projects that will help support your operation. So in other words, your entire research lab doesn't depend on your grant alone.
Right.
You can have funding from other projects, because universities typically do not fund research. They'll fund teaching,
But they
but
won't
not
fund
research. I mean, there's small grants floating around in some places, but they don't. And I think a lot of trainees probably are not aware of that. The expectation is, if you're going to do research, you got to get grants. Because actually, this is a good deal for the institution because of the overhead generated by the grants, which a lot of us as investigators would argue it's too much overhead because it should go to the investigator.
Got it. Well, I end every podcast interview by asking the question about legacy.
Yes.
You have already invested 35 years of your life in doing research and help mentor people and build everyone's careers as well as yours. So looking back, how would you like to be remembered by your peers and by your students? What would your legacy, what would you like to be, your legacy to be?
I think that I was as a good colleague, and I think especially that I helped, from an administrative standpoint here, that I helped advance the careers of both the senior people and the young people here, because we have a whole range of ages here. I'm probably about the oldest guy here now, but and in that regard, I particularly like working with a lot of the trainees. They're not my trainees, but I've been around so long, I'm the only one that knows how to do certain things. So age really counts for something, so I can show them in there technically, because I like to do experiments. So I help them out a lot with that. So I think that's how I would. I mean, I made some contributions to pH regulation field, but not by myself. That was a collective operation, particularly with my colleague Richard Von Jones at Oxford, and my other colleague at Oxford, Pavel Swiatek, and they've been great collaborators. And I think we have collectively made really significant contributions to the understanding how heart cells regulate their pH. But that's okay. I mean, science gets changed. It may be 10 years from now, that'll all be thrown out, although I don't think so. But I'd particularly like to be known as somebody that really tried to help people in their careers to become better scientists. That's the main thing for me.
Got it. Well, thank you, Dr. Spitzer, for taking the time to join us. And with that, we'll wrap this episode.
All right. Thank you very much.
If you liked what you have heard, I encourage you to share this episode with a friend. I'd also love to hear your thoughts on how you are striving to be a catalyst. So I invite you to leave a comment on the Catalyst's website. Thank you for listening, and until next time, connect, discover, transform.